What is volcanology? So volcanology is the study of volcanoes, as mentioned, but it's also a special kind of earth science. So earth science is the whole bunch of different fields that help us look more closely at our Earth, our planet Earth, and understand how it works, right? All of the different cycles that happen, how it works from all the way down into our core, all the way to the very, very top parts of our atmosphere that touch space, right?
There's a huge mountain with really, really hot lava.
When it erupts, it sends out a lot of smoke.
So it's really important that we study volcanoes because they can have really big global effects when they erupt. And even if it's not a global effect, a local effect on the people nearby still matters a lot. So no, Earth has not always looked the same. But how could we have gotten from Pangaea to the continent? This was only 200 million years ago, which means that there was life that used to live on this one big continent that is now spread out across the whole globe. It's continental drift. And because the world is actually comprised of plates called tectonic plates, these plates move in relation to one another. And so those plates went from being all attached together as Pangaea to cracks forming along some of these boundaries, these plate tectonic boundaries that then led them to separating out. And so these black lines that you see here are all tectonic plate boundaries. These red arrows show how they're moving away from, towards, or against each other. Let's look at how the plates are moving. So over here in California, the plates these arrows show are that they're moving kind of side to side, right? These ones, all right here, all four of those points, show that they're actually crashing into each other, right? The arrows are pointed at each other. And so we're going to consider all three of these types of plate boundaries. The transform, where they slide across each other, convergent, when they crash into each other, and divergent, like you see here and here, where the plates actually move away from one another. I'm going to show you the first example. So these are my two plates, and we want to know what happens when they move up against each other, right? So if I put them down on top of my asthenosphere, if I just let them go, they're going to go and float away. And that's what would happen if our plate tectonics didn't have other plates to bump into. They would just float away on top of our asthenosphere. So when I have two plate boundaries like this that are moving up against each other, they just kind of scrape side by side. No, this doesn't cause volcanoes. Look, nothing's happening to our plates. They're just scraping. And instead, this is what actually causes a bunch of earthquakes. We have it when plates move apart, something called divergent plate boundaries. And when they move together, something called convergent plate boundaries. So when you have a divergent one and they're sitting on top of the asthenosphere, they go from being pressed up against each other and then let them separate. And so what you'll notice is that magma actually fills the in-between. My bubbles are popping. But magma builds up in between the two divergent plates, right? That's what allows this to happen, is as they float away, we get magma in between. And so that can lead to volcanoes or other things, sometimes deep inside the ocean. But for the most part, divergent plate boundaries, plates moving away from each other, don't necessarily produce volcanoes. I have my two convergent plate boundaries, right? So I'm going to put them on top of the asthenosphere, and they're going to crash into each other. Are you ready? And they're going to crash and crash and crash. And look, I know there's a lot of bubbles, but do you see that I actually have a gram craft per mountain in there? I have a convergent plate boundary. You can form mountains. And volcanoes are what? They're mountains, right? We defined them that way. We talked a little bit about how volcanoes might have caused an extinction in the Earth's history. But if we didn't have volcanoes, we wouldn't have the nice atmosphere above us that helps protect us so much from space and provides us with the oxygen that we need to breathe, right? Today, we're going to talk about how do volcanoes erupt and what is lava. So a volcano is an opening on the surface of the Earth that has a pool of magma underneath it. And when pressure builds up in this pool of magma, gases and rock have to shoot up through the surface, and that's when an eruption happens. And they spill over and they fill the air with lava vapors. Who remembers what magma is made of? Lava and magma, here's a secret, they're technically the same thing, but magma is molten rock that's underneath our surface, underneath the surface, trapped inside Earth. The moment it comes out and is on the surface, then it's lava. How does pressure build in a volcano, right? A convergent plate boundary. So when we have a convergent plate boundary, like those arrows show, the plates are running into each other, right? And these plates float on top of our asthenosphere. Here has all this magma. So when the plates are facing each other like this, right? When they're running at each other, we have a convergent plate boundary and they're sitting on top of magma. When the two plates are running into each other, if one of them is weaker than the other one, it's going to become a subducting plate. They've crashed into each other and one is falling down, right? And so when it's very, very hot, all of the water from this rock escapes. But when the water escapes, it's very, very hot water. And so it's actually steam. With all of the steam from the water, it gets really, really hot. It melts the rock. You get this magma chamber. And once you have the magma chamber, do you think the rock stops melting? Underneath the surface, this magma chamber keeps building, right? It keeps growing. There's more steam in it, which means that can be more gases in it. So all of a sudden, this is full of magma and gases. I'm gonna add that, right? And so when it's so full of all of this, right? Because the other subducting plate's still melting, eventually it has to break through. It has to come out the top into the surface because there's just so much pressure there. It has to explode. But it doesn't always explode. Sometimes it explodes and sometimes it just breaks through. And so you can have two different types of volcanic eruptions. A big explosive one where rocks still flying and lava goes flying and there's ash and there's dust everywhere and you can see it all the way around the earth. Or you have something known as an effusive eruption. And an effusive eruption is nice and slow. It's still dangerous, but it's not as crazy dangerous as an exploding rock one, right? There are two different types of lava and both of them are shown here. You have something called mafic or mafic lava, which has a lot of iron in it. So it has a lot of metals in it. Or you could have felsic lava. And felsic lava has less metals in it and more other stuff. More silica, more carbon, that kind of stuff. So, fun fact, the felsic one is the one that explodes. This one is when you get a nice and slow flow of lava. They look like two different rocks, and that's because they're made of two different kinds of stuff. And that's why they lead to different types of volcanic eruption. Okay, so I have 4 different types of rocks here. And this is a basaltic rock. So if you see, do you all see those little holes in it and everything? Yeah, so this used to be lava. And so this is from a lava flow where it was really slow, right? So it was mafic. And so if you see all of these bubbles, well, all these holes, those are basically bubbles that popped while it was becoming solid. And then this is my felsic rock, also made from felsic lava. So this has a bunch of quartz and other things in it, but you can see it looks kind of similar to the one I showed you on the picture. Does anyone have a guess what this might be made out of?
Sand. I think it's salt. I think it's sand.
So this is actually made out of ash. All the bits that come from a volcano, they get shot into the air, but then settle somewhere else. All right, so you ready to see this eruption happen? It's gonna happen fast. Make sure to pay attention. Whoa! Isn't that crazy? Look at all the bubbles. Isn't that wild? Look at that. It's filling up the whole bucket I put it in. So that's one type of explosion or eruption that can happen. But you noticed it wasn't really explosive, right? Nothing popped off. It wasn't that dangerous. Things just flowed out, right? So that's kind of what can happen with effusive eruption. We're to show you the difference between the different types of viscosity. We're going to host a little race, okay? And the race is going to be between honey, oil, and ketchup. Oil is definitely winning, isn't it? Honey's not too far behind, and ketchup's only barely moved. But, so you see how slowly my ketchup's moving? That's the same rate that lava would move on my plate right now, if it was there. So, we have my waters down here, and this is how you should hold your Alka-Seltzer. So once you open it, put it on the lid and hold it like this, okay? So I'm gonna put this Alka-Seltzer in, and I have to close it really fast, and then I'm gonna put a lid on mine, but we'll watch it explode together, okay? So give it just a second. Oh, did you see my lid pop out? That wasn't very exciting. If you shake it first, it'll be very exciting, okay? What is volcanology?